Hello, good morning, good afternoon, or good evening, wherever you are on this beautiful planet of ours. Welcome to Sustainability in Your Ear. This is the podcast conversation about accelerating the transition to a sustainable carbon neutral society. And I'm your host, Mitch Ratcliffe. Thank you for joining the conversation today. It's going to be an interesting one. You know, the global push for sustainability has reached a critical juncture, particularly in industries traditionally associated with high environmental impacts, such as chemical manufacturing and mining. These sectors, vital to the global economy, are also significant contributors to carbon emissions and environmental degradation. However, innovative biomimetic approaches are beginning to transform how these industries operate, making sustainability not just an option, but a driving force in industrial innovation. And today we're joined by Tara Karimi. She is co-founder and chief scientific officer of Cemvita. She and her brother Moji bring unique backgrounds, Moji in petroleum engineering and Tara in biochemistry, to the challenge of converting CO2 into the raw materials, which are known as feedstocks, for new chemicals, materials, and potentially even food products. They use a synthetic biology to turn a greenhouse gas or other materials into a useful resource. Cemvita's breakthrough is just one of many CO2 capture and conversion strategies that could drastically reduce the carbon footprint of industries that are often criticized for their environmental impact. And we'll delve into the science behind Cemvita's innovations, explore the challenges of introducing sustainable practices in established industries, and discuss Tara's vision for a future of industrial sustainability. You can learn more about Cemvita at Cemvita, that's spelled Cemvita, cemvita.com. And we will get to the conversation right after this quick commercial break. Welcome to the show, Tara. How are you doing this morning?
I'm doing great. Thank you so much for having me.
Well, thank you for joining us. Cemvita is a really interesting company with a lot to get into during the conversation, but you co-founded it with your brother Moji, who's a petroleum engineer. You're a biochemist. I'm curious, how did the two of you begin to talk about bringing your skill sets together in order to create a company and go after a sustainable source of feedstock for a wide range of industrial processes?
Yeah, well, great question. Sustainability always have been a passion for both of us, and always we wanted to do a work related to the sustainability and how we can protect our planet. And we are siblings. We love the scientific and technical discussion. And it happened that both of us worked in Houston around 2016.
Mhm.
And we shared a lot of ideas across these two disciplines. And at some point, we decided, let's start a company.
So, what did you focus on first? And having worked with my brother at least once during my life, it was not always easy. How did you arrive at how you were going to go out about collaborating? I mean, that process is unusual in the wider context of life, but within a family, it's even more complex.
Yeah, I can see that. For us, because we complement each other, it worked perfectly. And I think we both of us have the same passion, same vision, and we are from two different industry, and we complement each other. So it worked well. I am from biotech and industry, and Moji is from energy industry. But both of us have the same vision in terms of the sustainability and protecting the planet and doing something significant and having a contribution uh, on the climate aspect. So that helped us to get together.
Now, I know it's a complex thing to describe, but can you briefly summarize what the science and production processes involved in turning CO2 into an industrial feedstock involve?
Yeah, it's all inspired from nature. Science that we are working on is inspired from nature because we really believe Mother Earth uh, is the best model that we can learn from. And the same way that, for instance, in the nature, carbon dioxide can be converted into
Mhm.
different materials. So, for instance, in the plant, it converts in variety of different molecules, including cellulose, um, all aromatic molecules that you can find them in flowers. There are several molecules that can produce through biological processes, and we can learn from nature. So for instance, in plant, as I mentioned, is through photosynthesis, and then you can see similar aspects in marine creatures, that carbon dioxide can be calcified
Mm-hmm.
and precipitated, or can be calcified and be a part of a creature. So we look at nature and we define those biochemical reactions, and then we replicate them to increase the efficiency. And today, with synthetic biology and biotechnology, there are several tools that basically we use them to produce different chemicals at larger scale. And a lot of those tools, I brought them from pharmaceutical
Mm-hmm.
industry. We use them for making different sustainable products, and we adapted them in larger scale for chemical production.
So you don't use a lot of heat to crack these molecules. You're using microbes more widely in order to do so. Can you talk about the environmental impact, the difference in environmental impact from traditional production, for instance, of the sustainable oil that you're making, and traditional oil?
Yeah, that's the beauty of biological systems. All of the reactions in biological systems happens at ambient temperature and pressure. Uh, which is a big differentiation compared to the chemical reactions, that normally we need to increase the temperature or increase the pressure, and then that means we need more energy. But in biological systems, all of the reactions happens at low temperature, low pressure, mostly around ambient temperature and pressure. So then that means the reaction by itself has low carbon footprint. And
Uh,
it happens because of the enzymes. So
Okay.
in biology, enzymes, we call them also biocatalysts.
Mhm.
They are able to run the reactions at lower temperature, and that's the main benefit.
When we think about your manufacturing environment and a major oil refinery by comparison, there's a lot less heat being generated, therefore a lot less energy going in, lowers the overall impact of the process. Does this biomimetic approach produce any byproducts which might be toxic or that we need to be concerned about in the environment?
Great question. So it comes to the design from
Hmm.
the initial design. The short answer is, if we do the design for a specific molecule, and then we choose the right strain, we don't have side products that is toxic, because we start with a strain that, for instance, has been used even in food industry or has been used in agriculture. So we know this strain doesn't make toxic elements. For instance, a lot of times we use a yeast strain that has been applied in the brewery. So we know those normally don't produce toxic uh, molecules. And then we add a specific gene, for instance, for production of oil or production of ethylene molecule. And then also in nature, normally cells, they only work on enzymes or genes that they have. They don't make extra things. They because they need to save energy. And enzymes are very specific compared to chemical reactions, that a lot of time we have so many side products, and the downstream processes and refinery processes are very long. So to isolate the side products in biological systems, if you add a specific gene, normally the cell mostly produce that gene, not too many other side products, because enzymes are very specific, and then cell also wants to save energy as much as possible.
So what can you make? We're talking about carbon and oxygen. You break that down. What can you make from CO2?
So many molecules, because carbon is the building block of life. carbon is the building block of living systems. Therefore, all molecules that we can find in any living systems, uh, we can we can produce them. The
Hmm.
rest of it is about how to optimize to make it economical. So if you look at nature, um, we can find thousands of molecules that can be produced through biological system, through genetic pathways. And today, with tools that are available, we can go and search all different molecules and then do uh, the back calculation or the to find the specific gene and then produce that inside a cell. So there are so many things that we can do. The rest of it is about which product is the priority, and then we start from there. Or which product can be considered as a feedstock. So we start from there, and then from that feedstock we can make different products.
So Cemvita has been working across a number of different industries already. I want to talk about just a few of the technologies you're working on. The first is, tell us what gold hydrogen is and how you got involved in producing it. Where are we going to see this in our daily lives begin to make an impact?
Yeah, so gold hydrogen is a type of hydrogen. It's a biological hydrogen that we
Okay.
produce it from waste oil in subsurface. For in reservoirs, always at the end of their life, there is about 30% of the oil remained in the reservoir.
Hmm.
Which because of the low pressure, it stays there, and then the field become abandoned.
Right.
What we do, we have microbial strains that we isolated them from soil, and they are able to degrade oil and release hydrogen.
So does that mean you're injecting that into the oil reservoir to then pump the hydrogen out, or do you pump the remaining oil and then process it? I'm just trying to follow how it all is put together.
Right. So if we inject the microbes, it's more economical, basically
Okay.
because we convert the reservoir to a bioreactor. In the reservoir already there are microbial strains like methanogens that they
Mm.
produce methane. What we do, we increase the population of microbes that they produce hydrogen. So instead of production of methane, then the reservoir produces hydrogen. And like I said, most of these strains are isolated
Mhm.
from reservoir or from soil. So they survive in that environment, which is high temperature. Sometimes they are high salinity, high pressure. They already adapted with that environment.
So the oil rig is replaced by a hydrogen pump. You're pulling the gas out once it's produced.
Yes, we isolate hydrogen or we extract hydrogen.
Interesting. Now, another thing that you introduced in July is a sustainable oil production process that produces about 330% more than previous methods. Tell us about first, what's a sustainable oil in your definition, and how are you applying that in partnership with customers?
So for sustainable oil, we use carbon dioxide and other sources of waste carbon. And through biological processes, we converted to sustainable oil, which basically is C16, C18, and is identical to palm oil, um, and then we have another version of it, it's which is more like coconut oil
Hmm.
or soybean oil. uh, and how we did that, because the genes for production of soybean oil, palm oil, are already existing in the nature. What we did, we identified genes similar to this in other microorganisms, or we replicated those genes in our library of microbes. So our strains, they produce oil from carbon waste. Then we use that as a feedstock, and we make different products, including sustainable aviation fuel and other products for instance, cosmetic industry and personal care.
Sustainable aviation fuel is a particularly hot topic. We know the impact of travel is vast. How much can this scale up? Do you believe as a society, not just Cemvita itself, but as a society, can we produce enough sustainable aviation fuel in the next 20 or 30 years in order to really make a transition away from petroleum?
Yeah, so for now, actually, the feedstock, which is coming from agriculture, is a bottleneck.
Mm-hmm.
Today, sustainable aviation fuel is produced from soybean oil
Mm-hmm.
or from cooked oil, but there is not enough soybean oil available to make sustainable aviation fuel for the demand that uh, we need to cover. Our technology utilizes waste to convert it to sustainable oil. And always there is so much waste. There is so much carbon dioxide and other sources of carbon waste that we use it to make sustainable oil. I think if we look at the waste as a resource,
Mm-hmm.
then we can produce enough sustainable aviation fuel. But if we rely on agriculture, it's not possible.
So that's interesting. Thinking about seeing one organization's waste as another organization's feedstock is really the key to beginning to unlock the circular economy. So, besides agricultural waste, what other materials can be converted by this process into sustainable oil?
So also carbon waste from industrial sources,
Okay.
including glycerol, organic acid. There are so many other waste from the industrial aspect that can be converted um, to products like sustainable oil. And I think if we look at the different industries and defining and categorizing their waste resource, their waste stream, then we can consider them how convert them to valuable products.
Does industry need to do a better job of promoting amongst other companies the fact that they have these kinds of what they see as waste streams that might be turned into something of value? Should a company be thinking if it produces a carbon-based waste product, calling Cemvita to find out how to turn it into something of value?
Yeah, that would be awesome. I think that that's what we need, and we can work together to return waste to valuable products. And that's something we really inspired from nature. In
Mhm.
nature, there is no waste. Everything recycles. Waste happens when us as humans we produce something and then we don't know what to do with the leftover. But in nature, everything recycles, and I think we need to be in harmony with nature. um,
We certainly have a lot to learn. And really, that's one of the concerns that I have as I look at what we're doing to the planet, is where we're racing as we reduce biodiversity, sources of the kind of innovation that you're describing. How much can we learn from nature? It feels like we're at the 1% level of all the knowledge we might get out of the world in order to produce a sustainable economy. How do you explain that to somebody who's thinking about, for instance, starting a soybean growing operation in the Amazon? How can we explain to them that there are better ways to source materials of value?
You are right. We are just scratching the surface. There are so many things we can learn from nature. But the good thing is that in other industries, already there are tools are available
Mhm.
that we can adapt them for sustainability purpose, or we can adapt them for the circular economy aspect. For instance, in biomedical sciences, there are a lot of tools that we use them to explore the DNA sequences and genes uh, for production of vaccines or for production of different pharmaceutical products. The beauty of nature is that nature has only one language. So the genomic language that exists in nature, it's the same thing. So all of the living system, they have the same genomic language, which is made of ATGC.
Mm-hmm.
So the subunits are the same. That means technologies that are developed in medical sciences can be adapted for other industries because the baseline language is the same.
I want to explore more about this language and what you can produce, but we're going to take a quick commercial break. We'll be right back. Now back to the conversation with Tara Karimi. She is co-founder and chief scientific officer at Cemvita, a Houston, Texas company that is working to convert CO2 into usable raw ingredients for products and packaging, amongst other things. Now, Tara, one of your other subsidiaries, Endolith, is doing something incredible with microbes, which is refining lithium. Tell us how that works, and where are you in the process of commercializing that technology?
Yes, so the same way we adapted the biotech for CO2 conversion and converting waste to value, we also came to other industries, including mining.
Mm-hmm.
And the philosophy is that if we want to do the energy transition, all different aspects needs to be in parallel. So we need lithium. If we are moving forward with the clean energy, we need so much lithium and copper. Um, and then we thought about how we can make these processes more sustainable.
Mm-hmm.
So for the leaching of copper and lithium currently in the mining industry, the process needs a lot of acids,
Yep.
mostly sulfuric acid, um, and that has a huge environmental impact. What we do, we try to replace those with organic acid and bioluxeviants that they can do the leaching process, but with less or very low environmental impact. Also, these processes again require less energy.
Mm-hmm.
How it works, we identified a special microbes in soil that they can do oxidation reduction reactions and help with the leaching of copper and lithium. So we use these microbes to do the job instead of adding sulfuric acid to the system for the leaching process.
So typically, when my exposure to lithium processing has been vast evaporation ponds, is this still set in that kind of an environment, or is this done within a closed system like a bioreactor?
Yeah, so the first part is in the bioreactor. We
Mhm.
need to culture these strains to increase their population.
Mhm.
Then we have columns. So basically, we pack the column with the ore, and then we add the microbes from soil, and then we let them to stay and go through the leaching process. We run it in columns for several times,
Mhm.
and then when we see it's optimized, then we apply it in the field as well. But most of our processes are in columns.
What would that look like? I'm trying to picture, is that vertical stacks of material that are contained in what looks like a silo, for instance?
Yes, they are very tall columns
Okay.
and packed with ores. And then we add the microbes to do the job. And then how these microbes function, they do oxidation reduction reaction uh, with a special minerals, including lithium, and then they release them. Another specific part is that because enzymes in these microbes, they function specifically,
Mhm.
so the ore is more pure after the process.
Now, how does Cemvita assess an opportunity going from discovery through commercialization and production to ensure that the technology is not only, environmentally beneficial, but economically viable for the industries that you're going to be selling them to?
Yeah, we work very closely with our partners from industry, even from the very early stages of technology development. We work very closely with our partners. We listen to them. We get a lot of feedback. So there is a very close feedback loop between us and our industrial partner. So they tell us specifically what should we do, what
Mhm.
shouldn't we do, what is economical for them, at least in short term, what is not economical for them. And we focus in short term goals, in midterm goals, and longer term goals. So, and a lot of times we repurpose the existing infrastructure based on the
Mhm.
feedback we hear from our partners in the industry.
Do you find that the materials you're working on, that you're applying the microbes to, can be reused in a variety of ways in your process to produce different things? I've always wondered whether or not there isn't a lot left over that could be used for other purposes.
A lot of times, actually, it happens because waste from one industry can be used in another
Mhm.
industry. So yes, it happens.
Do you find that companies are really ready and looking for this CO2 to feedstock transition to happen in their processes? Is it hard to get their attention, or are you finding that they're coming to you looking for these solutions?
It depends, I think, in the core values of companies.
Mhm.
Some of them, the environmental impact and taking the responsibility on their ESG is a big part of the core value and their culture. In some, it's not that priority. So we start working with companies that they really consider it as one of their major core values and culture.
Do you find that the population of companies with that kind of core value is increasing, or are you seeing a change in thinking generally?
Yes, I see it's increasing. Even like we are a pretty young company. Since
Mhm.
2017, we started the company. We already see the number of companies that they consider decreasing their carbon footprint is increasing. So yes, it's promising that more companies are trying to decrease their carbon footprint.
Now, one of the elements of the economic model that is emerging is the value of the carbon captured and prevented from being released into the atmosphere, which is often expressed in the form of a carbon credit. Is carbon credit revenue a key component of your model, or can you get by entirely on just the simple production process revenue?
We try to avoid considering carbon credit in our business model. We try to, from the beginning, we try to make the process economical
Mhm.
uh, as much as possible, because carbon credit can change easily.
Right.
It's not something you can rely for the next 10 years. We try to repurpose a lot of existing infrastructure, and then bring more innovation to decrease the cost, so the process by itself is viable.
Now, shifting gears a little bit and thinking about the supporting this process and this new economy that's emerging, do you foresee a need for widespread reskilling in the workforce in order to support all the work that you're doing in your various manufacturing facilities? Is this the beginning of a new challenge for all the workers who might have been working at oil refineries in the past? Are they going to need to learn something entirely new?
Yes, I think with a lot of new policies, definitely there is a big need for shifting toward the cleaner
Mhm.
uh, energy. And then that means, yes, the workforce needs to be trained and prepared to fill the gap.
What are the skills that we're going to need?
So, a skill set for new technologies that are focused on recycling, for instance, as
Okay.
you mentioned, or innovation in terms of renewables.
Mhm.
There is not enough workforce for this type of new technologies, and we work with locally with universities to train to train students for this type of skill sets.
So does that mean that we need more chemical engineers, or is somebody who simply worked in a production environment in the past going to be familiar with and understand how to manage the process?
Right, in a sustainable way,
Yeah. Right.
considering the decreasing the carbon footprint, for instance. So,
Mhm.
in a lot of chemical processes, we need to do energy and mass balance to make it economical. Now, we need to do the carbon balance as well. And there are not enough skill set around that part. So, basically, in addition to mass balance and energy balance, we need to do the carbon balance as well and making sure all of them are in balance. It's not just one or the other one. Three aspects needs to be considered.
So if somebody were to ask you what they should go to college and learn to do, what advice would you give them in terms of picking a career, really participate in this sustainable economy that's emerging?
Great question. I think considering the need, new technologies or even interdisciplinary technologies, I think that's a critical point to understand other like in a multidisciplinary way, having a holistic look at different technologies that currently are available and
Mhm.
how we can connect them together and how we can merge them together to apply it for sustainability, because a lot of technologies actually exist today. So and
Right.
how we can repurpose them or how we can learn from them for sustainability. One aspect is AI, definitely, and
Mhm.
large data. The other aspect is the tools available in biotech. They are already established in pharmaceutical industry for production of clean products, how we can use it for sustainability. In the chemical engineering, the same. So
Mhm.
there are a lot of tools available for carbon balance analysis, energy balance analysis, how we can merge this type of technologies to get the best for sustainability purposes.
It's really interesting that you described the need for generalists for that holistic view, and the fact that AI is enabling that across domains by bringing the data into usable contact with one another. Is that kind of holistic view really the key to thinking about a sustainable economy? That you think of the web of relationships rather than focusing on one interaction as a basic strategy in your work?
Right. I really believe in that because if we want to really learn from nature, in nature, there is no boundaries between
Mhm.
physics, chemistry, biology. Everything are in harmony with each other. We as human define these disciplines just to make it easier for us to study. But in nature, all of them are in harmony. All of them are
Mhm.
very interconnected. So if you want to really solve issues related to waste energy, we need to learn from nature how recycling happens, and it's a holistic view.
So what's your long-term vision for the company? Is Cemvita, say, 10 or 20 years from now, the Dow Chemical of the sustainable economy?
Yes, that's one of our visions. Yes, absolutely. You want to take the lead and have a contribution, a big contribution in sustainability and circular economy.
How would you quantify where you're going to be? Do you think in terms of, I mean, obviously profit is one driver, but do you think in terms of having reduced or removed a certain amount of carbon in 10 or 20 years?
Yes, absolutely. And then for that, again, like I said, we work with our partners to define how much carbon waste they have. So, for
Mhm.
instance, we work with United Airlines.
Mhm.
How our contribution can help them to decrease their carbon footprint, and we work together. We define a specific milestones to reach to that goal, and that's a big goal, but we do our whatever we do our best as much as we can.
Do you think that Cemvita can be a net zero or net positive carbon company over the course of its full lifespan? As, for instance, companies like Microsoft are ultimately attempting to retire their historical carbon, are you going to be an example of a net zero industry?
Yes, absolutely.
And is that possible today, or is that a goal that lies out in the future?
Actually, it's possible today.
Good.
In but like I said, it depends on how we connect different parts of the industry together. It's
Mhm.
not just one aspect. If we look at the energy transition, there is a part related to removing carbon dioxide from atmosphere. There is a part that still we are producing materials.
Mhm.
So how we can decrease the carbon footprint of those materials, that's a different aspect. And then the other part is that if we are shifting toward the clean energy and we need more battery, so how we can also decrease the environmental footprint as we are extracting lithium and copper. So there are different aspects, and we need to we need to consider all of them. Otherwise, if we just remove carbon dioxide, but still we have a lot of carbon emission
Yeah.
for chemical production or for material production, it doesn't go anywhere. So all of them are need to be in balance, not only working on the capture part.
Interesting. It sounds like one of the roles that Cemvita could potentially play is the orchestrator of the various interactions of sources of waste to connect to potential sources of feedstock. How can there's a lot to follow here. How can people keep track of Cemvita's progress? And if, for instance, they have an industrial process they'd like to talk about, how do they contact the company and get that conversation started?
Yeah, we are expanding our operation
Mhm.
for the, because yes, we have new customers, and then we have several waste stream that needs to be converted to different products. So for that reason, to increase our capacity, we are fundraising at this stage to build our commercial plants. And then the first one would be in Texas, and hopefully we can have more in different states and internationally.
Well, I hope that that growth happens because it's certainly an impactful business, and I'm looking forward to seeing what happens. Thanks so much for spending time with us today. We appreciate it.
Thank you. It was my pleasure. I really appreciate your time as well. Thank you.
You've been listening to my conversation with Tara Karimi. She is co-founder and chief scientific officer of Cemvita. She founded the company with her brother Moji, who's a petroleum engineer, and she a biochemist. It's a great story, and you can learn more at cemvita.com, Cemvita, cemvita.com. Biomimicry, the art of learning how nature acts to produce the cornucopia of life-making materials that it produces, is essential to our scientific approach to production. The idea of biomimicry emerged only in the early 1980s, and now, 40 years later, we're seeing not just occasional innovations based on this, but potentially industry-transforming changes in strategy and environmental impact. But we still have a long way to go before, as Tara described, we reach a carbon neutral and still prosperous economy. Cemvita's approach, which combines organic and inorganic chemistry with the insight to see biomimetic alternatives to heat-intensive chemical refineries by, for instance, seeing a depleted oil well as a natural bioreactor to make gold hydrogen, or by replacing leaching ponds filled with toxic chemicals that refine various types of minerals or metals or lithium with enclosed non-toxic processing columns. All of these point to just two of the paths out of our planet-killing industrial models. And as we pursue that dream, we need to preserve biodiversity simply in order to continue to learn new environmentally responsible production methods. If we protect it, nature can be an open book in the age of AI augmented science. But if we've torn out all the pages, there will be nothing biomimetic to learn. So we have a complicated but hopeful map to follow if we preserve the examples in nature from which we are going to learn our sustainable practices. Biodiversity, protecting our planet's rich library of knowledge about how to make life, is essential to our progress as humans. And we'll continue to explore these technologies and the efforts to protect nature's rich knowledge here on the show. Stay tuned. And you can help spread the word by sharing this podcast or any of the more than 490 interviews we produced on sustainability in your ear. Folks, writing a review on your favorite podcast platform will help your neighbors find us. You are the amplifiers that can help spread more ideas to create less waste. So please tell your friends, your family, your coworkers. They can find Sustainability in Your Ear on Apple Podcasts, Spotify, iHeartRadio, Audible, or any of the fine purveyors of podcast goodness out there. Thank you for your support. I'm Mitch Ratcliffe. This is Earth911's Sustainability in Your Ear, and we will be back with another innovator interview soon. In the meantime, folks, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.